Hi and welcome to this section where we're going to use a computational tool, MATLAB here, to see how we can apply or solve some of the equations we have been dealing with in our linear algebra classes. So you can always get this set up by going to the computer lab of the department and asking the staff in there to help you with the installation, or you can also ask some of your friends who are in the second years and above to help you with the installation. So provided with you, or I'm going to share with you also a text, okay, of MATLAB exercises. Okay, it is a text. They are lecture notes from another university. However, we are free to use them because this work may be distributed and used according to the GNU general public license. Okay, so we are free to use them as long as we acknowledge that it is not us who did this. However, we can also modify in case we want and so on, but I'm pretty confident that we can be able to use this. So what I would like you to do is, after getting the setup on your computer, I'm going to share with you these notes, and all you're going to do is to try to learn how to do these things, and there's no better way to learn, especially computational stuff, except by doing it on your own. So we shall go through the sections, or let me say, chapter 1 of this book here, and the chapter 2 here. Okay, this is so far what we have been able to do, or what we are going to finish in the next maybe video. We have not yet looked at matrix inverses, but we are about to look at that. Okay, but most of the things in chapter 1 and chapter 2 here we have done. For 3 you can leave out for now because we have not yet done that. So the idea here is that you just go into this book, okay, and the easiest way of learning, like I've said, computational stuff, is by doing. So for instance, we go to chapter 1, which talks about linear equations in two unknowns. Of course, we started with larger systems. However, we would first start with these smaller systems to get to know. Now, don't mind about these instructions are not for you, they are for them, and they are systems on which they are learning. Our interest here is, we start here that we would like to solve some of these equations graphically, and then we consider this system here, 2x plus 3y equals to 1, and then x minus y equals to 2. Then we go through the explanations here, and then they tell us that we are going to transform each equation here into like the equation of a straight line. For instance, if you make y the subject here, we get that y is equals to 1/3 minus 2 over 3 of x. So you realize that this is just representing a straight line. Similarly, if we make y the subject in here, then y is going to be equal to x minus 2. Okay, so we realize that those two equations there can represent two straight lines for which we can simply plot. And the idea, like we did in class, or we said in class, I hope I mentioned it, that we can get the point of intersection, and that will be the solution for x, y, your x and y. Okay, the solution for x and y, the point of intersection of those two lines. Of course, we say that if it is in 3D, it will be the planes, but of course that is going to be hard to analyze if even it is in higher dimensions. However, then we studied other things like Gaussian, Roic law, and what. So you see them in here in the exercises. They will be well explained how we can use this to find some of those solutions. So starting with the easy one, then all you have to do is just to copy, these commands here, and maybe check on the internet or check in MATLAB help by maybe what it means by easy plot. Okay, so we shall tell MATLAB to draw these graphs. So at the MATLAB prompt, okay, so little terminology here. This is now the script. I'll be putting it in the script here. All you need to do is, if you install the MATLAB, you can always check for a simple tutorial on how to start on MATLAB, maybe 2-3 minutes. can tell you some of these basics here. Oh, maybe why, okay, I'll tell you. Oh, maybe let me do this and then I'll let you know why I have done that. So when I put here matlab here, this red means that there is a problem. Okay, there is a problem here whenever I see these marks here, this red. So because now I already know what the problem is, of course for it may take you some time, but eventually you realize how things are. So that is the problem with the quotations. And then if I have everything here is okay, but then I still see some underline. They're saying easy plot is not recommended, use fplot or f implicit instead. Okay, that is not such a bad error. Maybe we shall, of course we shall always see maybe easier ways of doing this, or much more efficient ways. So after doing that, we can save and then we can run. Okay, you can come here on the run button, or I will use the shortcut here which says that it is just F5. I can use F5 and then I run that. So what it simply does is that it's going to plot for me this line here. Okay, it plots, that is the straight line it has plotted. And what it has simply done is it has plotted this straight line, 1/3 minus what is it, 2 times x over 3 on this interval, -10 to 10. Of course, with time, now if I put a percentage sign there, percentage sign is simply it says that make this a comment, okay, so that you don't run this piece of line. So even if I run, there is no output here. So you will learn these things with time. Percentage sign means that. So someone else would have said that no, there are so many ways of doing this thing. Perhaps someone could have said that, okay, I am going to start with maybe saying x, okay, maybe there's a command which they call linspace. I hope I am using it well, which says that that one there, you can always type matlab help or even go on the internet to check what does linspace do. Okay, and then let us run this and then we see. Okay, I want to see the output here. So okay, maybe let me do something smaller here. Maybe what if I put, oh, this is linspace, maybe let me just put linspace and then I put -1 to 1, and then we see what it does. Oh, what did I do? Okay, then I run that. So what linspace does, okay, what linspace does, it simply gives us values from -1 to 1, but equally spaced. Okay, so it is simply giving us columns 1 through 9, columns 10. It is just giving us values from -1 through up to 1. Okay, so we shall see, we go to 0.11 until 0.5, 0.7, until we get to 1. Maybe then you can always check. I don't have some of these things off my head. Maybe if I want to say 1 to 1, maybe in the interval 0.5 spaced, I think I include that. Let me run that and then see that. Is it so? I'm not so sure, but it does. Let me run that again and then see. Okay, let me try 0.2 and then see. No, that is not doing that. So if I want, then maybe I could go here and type help and then I put linspace and then see what it does. So what does linspace do? So they say linspace, linearly spaced vector. Okay, linspace x1 x2 generates a row vector of 100 linearly equally spaced points between x1 and x2. So that is what we had when we just ran linspace -1 1. It gave us 100 equally spaced points between -1 and 1. Okay, but now linspace x1 x2 and n generates n points between x1 and x2. Okay, so that makes sense. So I can just come here and then I put, maybe I want just 5 equally spaced points between -1 and 1. Okay, so let me come here and maybe you notice that I was writing CLC. CLC simply means clear the screen. Okay, those are some basic commands which you can learn if you pick up just a book or any tutorial book here. So we are saying we are creating 5 equally spaced points between 1 and -1. Okay, so that means that we have the first one, we shall have a value of -1, then the second one, this one, then the third one, then the fourth one, and then the fifth one. So the first point is at -1, the next point is at -0.5, the next point is at 0, the next point is at 0.5, and the next the last one here is at 1. Okay, so if we said we want 10 of them, then we would see something different. Okay, it will give us these points here, I suppose these points here, -1, and then that up to 1. Okay, 10 of them. So based on that, now someone could have said, hey, I want to create a number of points from -10 to 10, lean space, 100 of them between that. Okay, so if I put a semicolon there, a semicolon simply means that don't run that line. Okay, so let me do this and then we'll see. So a semicolon simply says don't run that line. So when I run that, I simply see that I have what is it, just our name, the name of the file, which I called here. This is just the name of the file, TCEM and TDEM. Those are the two groups which are taking this course. And then here there is no output here. If I remove that and then I run, I have the output, but sometimes it just clogs your screen, so you don't want to do that, so you just put the comment there. So I have like that, and then what else? Then we know we want to draw our straight line. Okay, so we are going to say that, okay, now y, what was y according to our plot here? We wanted y is 1/3 minus 2/3x. Okay, y is 1/3 minus 2/3x. So someone could say it is 1 divided by 3 minus 2 divided by 3 times x. The star here in MATLAB will mean times x. So this is the value of y. Okay, maybe let us run it and then you see. So you see it gives us the value of y and so on and so on. Okay, for each value of x in here, then it comes and places here and computes the value of y, which is 1/3 minus 2/3 times the particular value of x it has picked. Okay, so I'm not interested in that now. Now next, there is also the plot command, since they told us that they give us a warning that easy plot is not recommended. So there is a plot command. Also, if you want to see that, maybe let us see this. You can come here and then type help plot, and then you see. So quite long documentation, but plot, it says linear plot with these two arguments x, y, plots vector y versus vector x. Okay, so it is important for us to know that they are of the same size. Okay, but of course they're the same size because x is lean space, that then for each value of x in here it got y and computed it as 1/3 minus 2/3x. So now we want to plot our two vectors, that is x versus y, and then we see the result. Okay, maybe I may write here figure in case I do not want to maybe overwrite the other figure which we had here. This is what we had previously. Okay, let us go back here. Maybe let me clear this so that it does not clog. So we come here and then we run. So you see, this is our new graph. This is figure 2. Maybe we can put them side by side so that we can see. This was the first figure which we had from the easy plot, right? And then this is our figure 2 which we have from here. So you clearly see that it is the same. It is the same graph. Okay, so there are so many ways of doing this, but of course you can always start with the easy ones, or whatever is there in the book you copy and paste and run. So what we have drawn here is the line here. Okay, so if you follow with that, then you just go. Now you know that in the next idea here, so let me just copy all of this and I'll explain it at once. So what is this piece of code here doing? So what is it doing? Do you know? We said that the red marks here mean that we have trouble, but I already know the trouble here, so we just, maybe in copying and pasting, it does not read some of these quotations, okay, clearly. And then you may ask, why is the quotation there? That is the syntax. If they tell you that this has to be in quotes, then you follow the syntax, the way the language is written, okay, the way it is programmed. So what is it doing here? Oh, maybe let us even check what is help. Easy, we want to check help easy plot. What is that? Okay, so it says that easy plot not recommended. Oh, I am not so sure why they say it's not recommended. Easy to use function plotter. Easy plot is not recommended. Use fplot or f implicit plot and so on. Okay, then you can read through the documentation, and maybe you can even tell us why it is not what recommended. Okay, now let me see what is that, what we are talking about. Maybe fplot. Okay, so fplot not found. Fplot for fl, sorry, they are saying fplot. I typed fl plot. Okay, so fplot is what I wanted to type, and I typed quite something different. Fplot function, okay, it inputs maybe a function. Plot, I mean, it takes the argument here, which is a function, plots the function f between the limits of the current axis with a default of that. Oh, so we can use fplot, then we put the function and then the limits. Okay, we are going to try that as well. Let's see. Okay, so we can use easy plot, but they are saying that we can use fplot instead of that. They are saying fplot, where is it? Here, fplot, then this is, they are telling us this is the function, and then we put the comma and then the limits. We don't put this in quotations. Okay, let's see. Okay, let us first run this, then we will run that as well. So what they are doing here is that they are just using this maybe function, which, I mean, command, which is not recommended. I'm not so sure why, to plot this function within this limit. And then hold on is simply telling us that, hey, on this graph here, just hold on, don't plot hold on, don't overwrite that figure, hold on, and also plot this other line, which we said is x minus 2. Then the title, you can put, you see, this is in quotation. They are saying your name. Maybe you can say that, what is it, this is the title, and then they are solving simultaneous equation. And then that is, we'll put up the grid, and then the hold off is now, maybe you are now removing that hold on. Okay, so we said if we don't want to run this other piece, what do? We comment it. Okay, so I'm going to comment this. Commenting means that we put the percentage sign, and do I remember the shortcuts? I think it is Ctrl T, Ctrl R. I'm not so sure. Yeah, Ctrl R. That's okay. Let me save this and then run. Okay, maybe let me remove all the plots there so that we can see easily, and then we run this. Yes, so this is what we have. So we have this one, the first line which we had, and then the red line. Of course, now there are so many other things which you can add. So the point of intersection here, which we can find graphically here, will be the solution to our line. So it is around 1.409. I guess it must be x is around 1.5 and y is negative a half. Okay, so the other one is 3/2 and the other one is negative a half. So some of that, yep. So let's see. So you can play around with this by just copying and pasting, and then searching for these meanings either in the MATLAB help or in the the what, on the internet. Okay, so let us try this fplot, which they said fplot, and then we just put the function, okay, and then the comma, and then the limit. Remember this, where was it? Help fplot. It is useful for us to follow how the syntax is written. So they say fplot, the function, then the limits, okay, and then the limits yes, are written in that format. Okay, let's see. So fplot, the function, and then the limits, and then hold on, then we have your fplot, then the function here, and then the limits, and then the title, and so on. That should be the same. So let us comment that, and then save this and try to run and see if it does not complain. Okay, oh yeah, okay, I think we are successful. Oh no, what is this? Okay, let me first remove all that and do CLC, and we try to run this again, and we see what it gives us. Okay, this is not nice. I'm not so sure why. Maybe we have to leave this in the quotations again, because I'm not so sure why it is giving something which is not nice. So we put the quotations here, and yes, here also the quotation. Yep, sometimes these things you can forget a thing or two, but the thing is, as long as you know your way out, then you can. So warning, fplot will not accept character vector in the future release. Okay, they are telling us maybe it is going to be changed or removed. Fplot will not create character vector in the future release. Use fplot at. Okay, now this is again now different terminologies. Okay, when you have got the feeling of this MATLAB, then you will learn what this at means. Maybe these are called function handles and so on. So they are warning me that it has given me the result here, but the usage is not so good what I'm using. Okay, but since it's our first time of plotting this, well, we can stick maybe to the easy one here, which does not give us any complaint or any warning, and that is just using plot as it is. So in here again, so in here we said we have the linearly spaced, then y, then figure, then we plot, then we can as well also add the title. Okay, copy that, and then we paste that, and then we say what could the title be? Yes, solving simultaneous equation. Yeah, okay, we can leave it at that, and then we run. So we have that. Yes, so we can do the same things, and then say maybe figure, plot. Maybe we can also do the other one, which is hold on, and then we plot also the second line. What was the second line? So hold on, then we plot the second line, and the second line or the second equation was telling us that y equals to, not that one, this one here, y is equals to x minus 2. Okay, so we come here and then we plot y equals to x minus 2. So y equals to x minus 2, and then we see what happens. Let us first delete that. Okay, oh, did I run? And yes, oh okay, we just did that, but we did not plot, so we have to plot it. So see, so we just wrote that, but we have to plot it as well. So I will delete that and then run this again. So we see, yeah, we have our point, and the point of intersection should be what we already saw around around y. I think we found around y is -1/2, and the other one was 3.2, something of that sort. my mouse is yep, around there. You just put the pointer. I don't know, mine is not behaving well for some reason or the other. So you put it around the pointer, and then the point of intersection there, you will get it as that. Okay, yes. So what else? Maybe we can always go back to the book. So it tells you the command hold on tells MATLAB to hold the graph and not erase it when we use. This is the same idea there. It is telling us don't erase the other previous plot. So editing help to help you in entering these lines. You can edit the line you are trying to, so you can always edit or check on the internet for even better, you know, commands which you can use. So is there a solution? Yes. Why? There is a point of intersection. There are many solutions you can always see. Is there no solution? You can always see from the nature of the graph. Is it not intersecting? Then you can see. There are many solutions, i.e. the graph is one graph on top of the other, so that they are intersecting at all points on all the lines. So those are some of the things you can do in case you are trying to analyze these systems of equations. There, do we have a unique solution, i.e. do they intersect at one point? Do you have many solutions, they intersect at many points? Or do you have no solutions, i.e. the line is not intersecting at all? So you can do that, and yes, you will have finished maybe your first introduction. So the introduction may be quite long here, but be sure to follow through, and of course there is always somewhere to start, and you can always start with that. Of course, there are so many other things which you can do, maybe like putting an X label, putting a Y label, and searching for what they call maybe a legend. So I'll just copy that from some other text I had here, and then maybe just illustrate that here as we wind up here. So we can put here our X label, and that is the terminology. That is the way the language is written. You put it in quotations, whatever you want to label the X axis. Maybe we can call it the X axis. Okay. Then we can say maybe this is the Y axis. That is what we want to call it. And then the legend is to label the line. So maybe this one here, so this one here, maybe you can see here. Let us do here, if we put help legend, and then you see what they tell us, that help legend. Okay, so they tell us here legend creates a legend with descriptive labels for each plotted data series. So it just gives a descriptive label for each of the data series, and then you can already see its usage here by telling us that yes, we put the names in the quotation. So here, for example, they can say X equals to that, then Y equals to that, then you plot X, Y, and then the legend, you put them in this format. You have first in quotations, then the comma after, then the second, then the third. Okay, and then even if you want to put the location and add various inputs, okay, to that. So like I said, you can check all of these in the MATLAB help or even on the internet. So as we wind up here, what is the legend here? We want to label this axis. It's very what it is representing here. So I put that, and then we are saying that it is representing 1/3 minus 2/3 x. Okay, and then I want to do the same. So now you realize that I do not have to copy again x-axis and y-axis again, because it is the same graph, because I said hold on, and it is the same graph on which now we are plotting this other line. So there is no need again to say x label and y label and so on. However, we need to put a legend, because we have been told that the legend is just giving a descriptive name to each plotted data. So the next plotted data here we want is, it is called x minus 2 and so on. So let me just do that and now run, and then see what we have. So we can see this, we have called it the x-axis, this we have called the y, the y-axis, and then we have our labels. Maybe this is too big, I don't know. The only label that is appearing is x minus 2. I'm not so sure why only that. Maybe we come here and check in our legend here, y label, legend, okay, x label, y label, then legends, then hold on, then plot x, y, and so on and so on and so on. Okay, maybe it is somewhere, I'm not so sure why it is only this, but let us run this again and we see. Oh, just that. Okay, okay. Why is it only this? Okay, let me try to maybe do that, comment that, and try to run it again with only one label. Okay, so I see one label is there, or maybe, okay, then I don't want to go beyond this, but I think the only reason the other one is not appearing because I see when I commented this second label x minus 2, I can see that the first label here is appearing here, which is 1/3 minus 2 over 3x, this one. So I think it must be just issues of space. I don't know, I can investigate that, but I don't think it's very important here. A point has been taken, we can always try to investigate that and so on. Okay, maybe just one thing just to play around. What else? Yeah, maybe we can even try, oh, there are so many things which you can really pick here and there. Maybe this one here, this is a command which is going to set the x-axis at the origin, because that is something I have seen is not happening here. Figure, maybe let us do that, let us save and let us run, and then we see where's the y-axis, the x-axis. Okay, at the origin, let's see this, let's see x-axis, figure, plot, xy. Okay, let's see. Okay, control, maybe, okay, the order perhaps here matters. Maybe we first plot and then we put it, okay, yep. So we first plot, okay, so the idea was first draw the plot and then fix the x-axis, the x-axis and the y-axis to intersect at the point of the origin here, and so many other things. So please do what I've recommended. You just go into the book and copy and paste some of these commands and just check some of them on the internet and try to run this. Okay, thank you, and see you in the next video. In case you have any difficulties, just put them in the comment section and we will start from there next time. Thank you.